So what I do for clarity is decouple all the various elements in our system into the 3 hydraulic cylinders in their own space and the 3 linkages. Like we did realize, the hydraulic cylinders are in tension as a result of an overall load W acting downwards and hence pulling these apart. That's the intent of this loading condition. So like I suggested previously, I first deal with the hydraulic cylinders and draw tensile forces or apply tensile forces at their extents. I've got FGF and FGF, that's the tensile force on this hydraulic cylinder. FCE and FCE again, that's the hydraulic, or rather the tensile force on this portion of that hydraulic cylinder. And you've got FBC and FBC, tensile force, hydraulic cylinder. And these tensile forces on this hydraulic cylinder result in equal and opposite reaction forces at the points of coupling. For instance, we've got an equal and opposite FCE over here, equal and opposite FBC here, equal and opposite FCE, and an equal and opposite FGF. So again, that's a whole lot of forces that we have uncovered by just focusing on the hydraulic cylinders and the loading conditions applied to these hydraulic cylinders. So what's left? What's left is a bunch of pins and perhaps one hinged support. So we've got a hinge support at D, and we know to have an X and a Y component associated with a hinge support. We have a pin at point F, which results in an F sub X and an F sub Y, that's vertically upwards, excuse the slant line. And we have an equal and opposite set of reactions, F sub X and F sub Y, because these 2 points are coupled through a pin. We have a pin again at point A, hence we've got an A sub X and an A sub Y acting downwards, and equal and opposite reaction forces at the associated point on the tub. So this is the overall free body diagram for our backhoe, and you would want to solve the rest of it, rest of the problem of static equilibrium based on this free body diagram. And for that, I will switch to a paper mode, which you should have through your Canvas page or through an email that goes out to the entire section.